what you should notice is on today's notes, there are the formulas from yesterday. So remember from yesterday's notes, the formulas that you use most often are those two right there. Because remember, we change everything to sine and cosine, okay? Now, remember, these formulas will be given to you on the test, okay? Also, these formulas will be given to you on the test, okay? You don't have to memorize them. You do need to memorize them for the CLEP test, okay? I would recommend making flashcards, okay? Personally, because I can't type some of this stuff in, okay, because the equation editor doesn't let you, I would highly recommend just writing flashcards by hand. Okay, if you want like colored paper to cut up and make it pretty, I can give you colored paper to cut up and make it pretty. That way you can't see through it, because I know white paper you can see through. Does that make sense? So if you want some colored paper, I can get you some colored paper, but I would make flashcards for these if I were you. Okay? So, how you're going to use these today is you're going to focus on using them using 30, 60, and 45 angles. Okay? And how they work is, for example, they might tell you that you have the cosine of 105. Do we know the cosine of 105? No, we don't. Because it's not, like, if you think of 105, so 105 would be, so this is 90, right? 105 is here. So this is a 75-degree angle here. Do we know the cosine of a 75-degree angle? No. Okay? So what you have to think of today is, okay, if I have the number 105, how can I make that into a 30, 60, 45? How you do this is you say, okay, I have 105. Which two of these added or which subtracted gets me 105? Well, what's 60 plus 45? 105. And so you're going to use the cosine of 60 plus 45 formula. Does that make sense? Okay, so you take the number, you look at these and figure out, okay, how can I add or subtract numbers here to get me 105? Okay, 60 plus 45 is 105, so I'm looking at the cosine of 60 plus 45. So then for my alphas over here, it'd be cosine of 60 times cosine of 45, because that's 60 and 45, minus sine of 60 times sine of 45. We know the sine of 60, right? We know the sine of 45. We know the cosine of 60, and we know the cosine of 45. So by breaking numbers up into numbers that add or subtract into them, we can use these formulas to solve them. They will always be a number that added or subtracted can become a 45, and then it's usually a 45 and then a 30 or 60. Okay? Any questions on that? Okay, are you ready to practice this a little bit? Okay, so let's look at the first example. It says that I have the cosine of 7 pi over 12. If you look at the directions above, the hints say change it to degrees. A lot of people, it's easier to look at degrees with adding and subtracting than the pi, the radians, okay? So what number do we plug in for pi to change this to degrees? 180. So we would plug into our calculator 7 times 180 divided by 12, which gets us 105. So this is the cosine of 105. So it's actually the problem we were working on above. What two numbers add to get you 105? 45 and 60. So you have the cosine of, I think I said 60 plus 45. It doesn't matter the order you put it in. You'll still get the same result. Okay? So now that I know that I have cosine and addition, I'm going to go above to my formula and use the cosine addition formula to solve this. The cosine addition formula, and I'm doing this off of memory, is it the cosine of 60 times the cosine of 45? Because this is my alpha and this is my beta. Is everyone okay with that? And then is it minus? And then it's sine of 60 times sine of 45. Is everyone okay with how I plugged those in? How I got from having this to having this based on the formula that's up there? Okay? Do you see why I don't have those memorized? Because they are complicated, right? Okay? So now this is what I have. So now I'm going back to these 60 and 45 degree angles to solve this. So if I'm thinking of 60 and 45 degree angles, I'm going to have, let's see, I have a 60 degree angle. So if I have a 60 degree angle, this side is square root of 3, this is 1 and 2, correct? Is everyone okay with how I figured that part out? What's the cosine of 60 then? Cosine of 60 is 1 over 2. Do you guys have that cosine of 45 is square root of 2 over 2 memorized? No? Okay. So then if you look at your 45 degree angle, this is 1, 1, square root of 2, correct? Is everyone okay with that? So then cosine of 45 is 1 over, oh, I'm running out of room, 1 over the square root of 2. So you have to times top and bottom by square root of 2. So that's square root of 2 over square root of 4. You guys see how that's square root of 2 over 2? So that's what gets plugged into cosine of 45. Minus sine of 60, isn't that square root of 3 over 2? So square root of 3 over 2. Times sine of 45, again, is this 1 over square root of 2. Which, when you simplify, do you guys see how you get square root of 2 over 2 again? So you find the equivalence, and now it's a matter of just multiplying these together and putting these together, okay? So 1/2 times square root of 2 over 2, isn't that square root of 2 over 4? Minus square root of 3 times square root of 2 is square root of 6 over, what would the bottom be there? Be 4, right? So you have square root of 2 over 4 minus square root of 6 over 4, which is square root of 2 minus square root of 6 over 4. That's your final answer. Sorry, I know I should have had more space here. I don't know why I don't. Was everyone able to follow my simplification curve? Okay. Yep, because 1 times square root of 2 is square root of 2. 2 times 2 is 4. Yep. And then 2 times 2 is 4 again. And then they have common denominators, so I can write them together. What other questions do people have? Kayla, you have a question? Okay. Seth, you have a question? Like in that second part? So what you do is, I see that I have cosine in addition. So I come up here where I have cosine in addition, and I rewrite that formula. So I said alpha was 60, so where I see alphas, I'm going to put 60s in. And where I see betas, that was 45, so then I put 45s in. It doesn't. You could have alpha be 45 and beta be 60, and you're going to get the same answer for all of these. So that's just telling you what your alpha and beta are. So it's just prepping you to plug in over here. Yeah. So it's not simplifying like we've been doing problems lately. This is like solving them. Other questions? Okay, so let's try another one. It says I have cosine of 15, correct? Cosine of 15. How do I get 15 from 30, 45, and 60? 45 minus 30, right? Could you also do 60 minus 45? Yeah. You're going to get the same answers either way. It does not matter which one you use. Okay? So I guess I'm going to use 45 minus 30 just because they're smaller, but it doesn't matter which one you decide to use. Okay? So I would say that this is cosine of 45 minus 30. Now I'm not using the same formula I just used because that one was the plus version. I need to use the minus version. So the minus version is that second formula listed. Okay? So again, I'm doing this from kind of memory. So you have to tell me if I write things down wrong, okay? So I think it's for cosine minus, is it cosine of 45, cosine of 30? Okay. And then I think it's plus, right? Because the last one was minus. And then is it sine of 45, sine of 30? Okay. Now, the previous ones we did cosine of 45 and sine of 45, correct? What were the answers for those two? Square root of 2 over 2 and square root of 2 over 2, right? Okay. What is cosine of 30? So that's one we didn't do because we did 60 the last time. So if we have 30 here, this is 1, 2, and this is square root of 3, right? So this one is square root of 2 over 2 times cosine of 30 is square root of 3 over 2, right? Plus sine of 45 is square root of 2 over 2 times sine of 30 is 1/2. So you're left with square root of 6 over 4 plus square root of 2 over 4, which is square root of 6 plus square root of 2 all over 4. That'll be your final answer. With these, you will find a lot of square root of 6s, a lot of square root of 2s in your process, okay? You will. It's just how it ends up working out, okay? Nope. It can't be simplified. You can't add things that are different numbers in square roots. Here? Because when over here we did cosine of 45 and sine of 45, we found it was square root of 2 over 2. So do you remember doing that in the pink part? Here? So we already did it, so I didn't show the work again. But if you wanted to show the work again, it's good practice. I'm just lazy. All right. So we are going to do this one because this is a different version that you're going to see today. So we have sine of 19 pi over 12. Okay, so if I plug in 180, sorry, I didn't. 285? All right. So I have sine of 285. Yeah, it is a big number. Okay? Now, obviously we see that 85. So what angle for sure is in this? A 45, right? So if we change this, this can be the sine of 240 plus 45, correct? Okay? So the question becomes, are we able to do a triangle at 240? We are. What kind of angle is it at 240? And what quadrant it is in? The third, right? So we can do 45. We've done that one a couple times, right? The 240 is a triangle down here at 60 degrees, because this is 180, so 240 is 60 degrees from 180. And we have to plug in our numbers. Now, if it's in this quadrant, the two side lengths are both negative, right? So this is going to be negative square root of 3 and negative 1. And then remember, our hypotenuse is always positive. So negative 1, negative square root of 3, and 2. And now we would use the sign addition example to solve this. So I would like you to see if you can solve the rest of this on your own. You're using the sign addition formula. Okay? And see if you can finish solving this one on your own, knowing this is the triangle you're going to use for your 240. Yes. Yep, you're going to do like sine and cosine of 240, and you're going to use this triangle to know what numbers you have from that. One square root of 2. All right, so I have the answer circled up there in blue, okay? I do want to warn you that if you're looking to the answer key in the back of the book, because the top, both of them are negative, I would not be surprised if they change this to a negative square root of 6 plus square root of 2 over 4, where that negative is plopped down in front. So just know if that negative is in front, okay, that negative would distribute. Those are the same things, okay? And I would accept either answer. I'll actually be multiple choice. So this would probably be the multiple choice answer. But know that if these are both negative, that negative can pull out front, okay? Because it distributes then back in. All right? No, we're not going to do a tan one. Tan one's similar. So we're going to jump to the other examples you're going to see today. So you are going to see again those even odd identities. Okay? So you are going to see again those even odd identities. I feel like we did that first one yesterday. Okay? So let's do it again quick as a reminder. So if sine is negative, what happens when that negative comes out? It's a negative, and cosine of a negative turns to a positive. So this one stays negative, this one stays positive, based on these identities that we have at the top, right? That we talked about yesterday. Okay? And then remember, if it's squared, It means we have negative sine of theta squared. That squared is on the outside of this problem. Plus, remember cosine turns positive. So this is cosine of theta squared equals 1. What happens when you square a negative? Turns positive. We can drop that 2 back inside now that we squared it positive. And doesn't this equal 1? Yeah. So we're done. Which one? Cosine or sine? This one? So once you square it and it turns positive, you can stick it back here. Yep. And this one, since I knew it was positive, I can just leave it there. Okay? I don't need to change it to this version at all. All right, so let's look at the next one. Same sort of thing happening. I have sine of a negative. What happens there? The negative stays negative. So you have negative sine of theta. Minus, what happens to cosine? Turns positive, and I'm done. Right? That's what the other side says. That's an uncomfortable one step. I don't like it either. All right. All right. So then what they're going to do is they're going to have you do the proofs like you had been doing, but they're going to put equations inside of them for you to solve. Okay? So we have cosine of a addition, right? So cosine of an addition, just so we don't have to flip back and forth, that's cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. Is that correct? Okay. Just so you don't have to flip back and forth. So this is the equation that we're using here. Okay? Remember, you're switching your left-hand side. My alpha is going to be pi over 2. My beta is going to be theta. You can switch it to 90. Let's do 90. I'm good with that. So we're going to switch it to 90, I guess. Okay? So now, let's change it to this version. So we have cosine of 90 degrees times cosine of theta minus sine of 90 degrees minus or times sine of theta. Okay? When it comes to 0, 90, 180, 270, and 360, I would highly recommend, instead of doing the triangle way, just looking at the graph. The graph of cosine looks like this, correct? Where 180 is in the middle. So if you have the graph of cosine, what is cosine at 90? It's right here, right? So what number is that? Okay, so this is my 90-degree angle. At 180, your answer is -1. At 0, it's at +1. What is it at 90? 0. So that's 0 times cosine of theta. You guys understand what I was trying to get you to say now? Okay, so at 180, 180 is the middle of it. It's a -1. I would use it anytime this is 90, 180, 270, 360. I would only use the triangles on the 45, 45, 90, 30, 60, 90s. You do get the same answer. Okay, so if you prefer the unit circle version, use the unit circle version. Okay? So let's talk about sine at 90. So if I look at my graph of sine, My graph of sine looks like this, where in the middle is 180. So what's sine at 90? 1 times sine of theta. What happens when you multiply something by 0? It's 0. So you have negative sine of theta left, which is what we wanted. The proof is your answer, yep. All right, so we have tan of 2 pi minus theta. 2 pi is 360. All right, so now we have tan and its subtraction, right? So we have to use the tan subtraction formula. Okay. So tan of alpha. All right, so tan of alpha plus tan of beta. Here, let me write it on the board. We're doing subtraction, right? Okay. Tan of alpha minus tan of beta all over 1 plus tan alpha tan beta. Okay? So now that's what we're plugging into for this problem here. I'm going to switch colors. I'm going to go to orange. Okay? So, knowing that, put it in all the same color. OCD taking place. Okay? So let's plug in what we know. We have tan of 360 minus tan of theta over 1 plus tan of 360 times tan of theta. Now, I would use the graph, but I feel like I know the graphs better than you guys know the graphs. Okay, so you guys want to use the unit circle on this one? Okay, so on the unit circle, 360 is here, right? And so that's the point 1, 0. What's your h every time? This one is 1, right? On the unit circle, it's 1. So this is what you have. Tan is opposite over adjacent. And remember, it's going to be y over x. Because if you draw a triangle, y is always opposite, x is always adjacent. Okay, so tan is y over x. Y over x is 0. So tan of 360 is 0. So you have 0 minus tan of theta over 1 plus 0 times tan of theta. So this 0 goes away. Do you guys see how this second part here equals 0? So that goes away. So you're left with negative tan of theta over 1, which is negative tan of theta. What this equals. Yep. Do you guys feel like we need to do more? What's the next one? Pi over 4. Do you guys feel like we need to do more? No? All right. Now, Becca, oh. So this is the same process as what we saw above, like up there. It's just now you have 2 of them that you have to write down instead of 1. Do you guys want to do, these are a little bit harder than the ones we did up there. Do you want to do some of these? Okay, so let's do this one first. We have sine of alpha plus beta plus sine of alpha minus beta is going to equal 2 sine of alpha cosine of beta. Okay, so first of all, we need to know the sine plus version and the sine minus version, correct? So sine of alpha plus beta is it sine or is it cosine first? It's sine. Sine of alpha, sine of beta, plus no, this one's cosine beta, right? Plus cosine alpha, sine of beta, okay? From our front page. I'm just copying the formulas from the front page that we're going to use. Sine plus. Now I'm going to copy down sine minus. So sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. Yeah? All right. So what I did is I saw these problems used sine of plus and sine of minus. So normally you have those in front of you, right? I don't have that luxury because I have to scroll. So I copied down the formulas we're going to use. That's all I did is I went above and I said, okay, I need sine of plus and sine of minus because that's what I'm going to use to change these. Is everyone getting that? We haven't done anything. I just wrote down the formulas we're going to use. Okay? Does it make sense though? Like, okay. So these are the formulas I'm going to use. So it says that I have sine of this plus sine of that I need to change. Okay, so I'm going to write down this first. So sine of this is sine of alpha plus cosine alpha sine beta plus, so now I'm to this, I have to write this down, sine of alpha cosine beta minus cosine alpha sine beta. Okay, so I replace each of these. I replaced this with this, and I replaced this with that. Things cancel, right? The second and the third thing, or second and last thing cancel. You guys see that? Cosine of alpha sine of beta minus cosine alpha sine beta. Those two cancel. And how many sine alpha cosine betas am I left with? 2. So I'm done. Not really. The thing is so this is nothing with calculus. We don't do this in calculus. Yes.
This is harder.
Mm-hmm. College calculus is easier than pre-calc. Mm-hmm. So when I was in college, pre-calc was the hardest math for most people. Yep. And in fact, usually I told people to skip it. Because in college, they make you memorize all these formulas for pre-calc. Mm-hmm. And a lot of kids aren't math majors, so they just want to pass the class. And so they don't really try. And then they don't pass the class. Because they don't make flashcards, or they don't memorize the formulas. They don't do what they need to do. All right? So each one today is going to be, okay, I have sine of plus, I need my sine of plus formula. I have sine of minus, I need my sine of minus formula. That's what each one's going to be. So like this one, what formula would I need? Sine of plus. So I have to take that sine of plus formula and write it down. Is this one of our formulas? No, because it's not plus or minus, right? So you're just going to leave that because it's already in sine and cosine versions, correct? Things cancel as you solve it. Do you guys want to do this one quick?
Yeah.
This one's a two-stepper as well. So I copy down this plus formula that I already have here. So I have sine of alpha cosine beta plus cosine alpha sine of beta all over sine of alpha cosine beta. There is, but what can you do with something that's in a fraction? You can put them separately. So not only can you take two fractions and say, well, x over 7 plus y over 7 equals x plus y over 7. So not only can you take two fractions and put them together, you can also take two things and separate it back. So this one is a separated back. And the reason I knew that is because when I looked over here, do you guys see how they're separate? There's two pieces. So it's telling me I want to separate this. So then I have sine of alpha cosine beta over sine of alpha cosine beta plus cosine alpha sine of beta over sine of alpha cosine beta. Okay, so I separated them. I can take fractions and put them together, or I can take a fraction and I can separate it in the same way. Yes? On this? It came from the formula. Yeah. That's where it magically appeared from. That's fine. A lot of them look like infinities when I look at them. But what happens here? They cancel, right? Cancel, so that's 1. That's where the 1 comes from. Plus, if I have cosine alpha over sine of alpha, what's cosine over sine? Not tan. Cotangent. And then, what's sine over cosine? Tan. And you're done. And because of how these formulas are written, it's always written where alpha's first, beta's second. So it'll always be written in the way that they're going to be over each other, and you just have to switch it to that new version. Okay? Are we at the end now? All right. So Becca wanted me to go over this and change it to evens. Odds. Okay, so I'll look it up and I'll change it to odds.